Hi children, welcome to our ICT learning. So this is English medium, local English medium academy, which supports you especially in English medium syllabus. So I have done up to grade 8 IT lessons right up to this. So you can follow them if you want to recap the things in grade 6, 7 before starting this. But this is basically starting the grade 8 series. So this is the first chapter, number system. So this is the first time we are learning number systems in IT learning path. But maybe you have learned these things in mathematics, but not in IT. So grade 6 and 7 didn't have any related chapter for this. So this is totally new. So you can start from here onwards, right? So use of number systems, right? Numbers, you're very familiar with numbers. Maybe you can count up to maybe millions or billions, I don't know. So, and you have learned numbers maybe from age of 2, just to count 1, 2 like that. So we use computers also, right? So, but problem is computers cannot understand human language itself, right? So that's why these numbers are very important in computer world, right? So because computers understand all these data instructions, text, numbers, images, everything as numbers, right? So it is common thing that humans are not very good at numbers, right? It's easy to talk in natural language and all these things, but when it comes to computers, they are more familiar with numbers. That's why number systems are coming in computer world, right? So if you see in this example, there are text, there is audio, there is video, there is images, but everything will be converted or represented as numbers in the computer memory. So computer is more familiar with numbers. So that's why number systems are coming here. Okay. So before going to computer world and all these numbers, we should learn what is number system, right? So number system is a method that you can represent numbers, right? So there are a lot of number systems, but usually you are very familiar with the decimal number system, right? 1, 2, up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those symbols are used basically in decimal number system, right? But there are so many number systems, and each of these number systems has a fixed number of symbols, right? So if you see in this table, you can see there are binary, octal, decimal, hexadecimal. So if we take the decimal, right, base is 10. I will tell what is base. Base is actually the number, like now they have given you the explanation. The base of the number system determines to which number system a given number belongs. Usually when you write the number, you should write your base. So because now think 0 belongs to binary, octal, decimal, hexadecimal. So if you just see a 0, you don't know what this symbol belongs to which number system, right? That is why base is very important, because if you put the base, you can tell, this number belongs to this particular number system. This is decimal number. This is a binary number. This is an octal number. You can identify that, right? So here in this, they have just introduced you 4 number systems. So you can see binary is having only 0 and 1, and base is 2. Right? So there are actually 2 symbols in binary, 0 and 1, right? And when it's come to octal, octal means 8 usually, right? So base is 8, that means there are 8 symbols, 0, 1, 2, 3, 4, 5, 6, 7. So remember 8 you don't write in octal, right? Number 8 is not there. And decimal, yes, you are very familiar, right? And normally in decimals, we don't put the base. 10, we don't put it. That's why this may be very new to you, right? Because in our maths books, we never put 10 as the base when you are doing, right? So that may be new to you, but other number systems, we must write them. The base is very important, because then only we can identify for which number system this particular number belongs to, right? So decimal has from 0 to 9 and there are 10 numbers in there. So base is 10. Hexadecimal, there are about 16 numbers and it starts from 0, 1, 2, 3, 4, 5, 6, 7, 9 up to 9. And then you have A, B, C, D, E, F, the English letters. And the English letters should be caps, right? So in grade 8, we are basically learning about binary and decimal number systems, right? So base, now can you see the base in these numbers, right? So the first example, it's about a binary number, right? So see 101, right? So that's the number and Z only 0 and 1 is there because it's a binary number system and 2 is the base. Can you see the base? So if you see this number, you know, this is 101 with the base of 2. That means it's binary number. See the octal example, 108, same thing. But their base is different. Base is 8. This is belong to octal number system. You will understand 101 in binary and 101 in octal are two different numbers, right? It's not the same. You will get the concept, right? Don't tell 101. 101, it's in decimal number system, right? We cannot tell in binary it's 101. It's 101. Okay. So a decimal you have 10 base, but normally remember in decimal we don't need to put it, right? Hexadecimal, it's 16 with the base. Remember there we have English letters. Understood? So that is the basic introductory level. You have 4 number systems, but from here onwards, we are learning only about decimals and binary, the conversions. That means if you have a decimal number, how to convert it to binary. If you have a binary number, how to convert it to a decimal, right? So decimal number system is what humans are most familiar with, right? So you can see the symbols there from 0 to 9 you have. So if you see now they have given a nice example with the symbols 1, 2, 3. You can prepare different numbers, right? 123 is the lowest value you can create with those three symbols and 3 to 1, 321 is the highest value you can form with those symbols. Hope it's very clear, right? And here they have shown you in the abacus. Remember abacus? You are in grade 8 now. Abacus you may have learned in grade 2, 3, 4 at that age, right? So 2, 3, 1 in these rods, can you see the balls are there? So in here, the one ball representing ones. That means its value is 1. 1 into 1 is 1. Can you see in the right hand side that 1 is there? Okay. And in tens column, there are three symbols, three circles are there. So actually that is 3 into not 1, 3 into tens. That's how 30 has come. And in the hundreds column, you have two circles. So it is representing 2 into 100. That is how 231 comes. Understood? So in this decimal thing, the place values are 1, 10, 100, 1000, like that. 10 to the powers only it comes. So you know 10 to the power 0 is 1. Do you know? In maths you may have learned it now. So remember 10 to the power 0 is 1. Anything, 2 to the power 0, 3 to the power 0, 4 to the power 0, any number with the 0 power, it's 1. So 10 to the power 0 is 1. So the place value is 1 there. So you can go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 into 1. So that's how the ones place is working. And then comes 10 to the power 1. That means tens, right? So that's the place value. Next place value is 100. 10 to the power 2, 100. Understood? That is how this 231 is constructed. Got it? So these place values will be different based on the number system you are using. Here it's decimal, yes, 10 to the powers. But if it's binary, it will be 2 to the powers. If it is octal, it will be 8 to the powers. If it is hexadecimal, it will be 16 to the 16th powers, right? Okay. Now see in the binary, same thing. Here it's very easy because we have only two symbols, 0 and 1. So binary digit, we call it as bits. So there are two bits, 0 and 1. So computer is mainly working in binary numbers, zeros and 1, right? So here, 101. So I told this is not 101. We'll see it's actually 5. You're representing 5 in decimal with 101 in binary. See the difference? Now here, 101, it's shown in Abacus. Can you see? The place values here, 2 to the power 0 is 1. It is same as the decimal number system. But second rod, it's not 10 to the power 1. It's 2 to the power 1. So the value is 2. And 2 to the power 2 or the 4 is the next place value. Can you see 101 how it is represented? 101. The last one is multiplied with 1 because 2 to the power 0. Then it's 0, 0 into the 2 to the power 1. 2 to the power 1 is 2. That's why 0 into 2, anyway, any number which is multiplied by 0 will be 0. Then 1 to the power 1 into 2 to the power 2. That is 2 to the power 2 is 4, right? So it's 4. 4 plus 0 plus 1, it is 5. Right? See, number 5 in decimals, right, is shown as 101 in binary. That's why I told you 101 in binary, 101 in decimal, 101 in octal, 101 in hexadecimal are not the same number. It's totally different because the place values are different. So the total final value will be different. Okay, so this is introductory. Don't be afraid. We have a lot of mathematical things to do, right? The necessity now we are going to convert from one number system to another, right? So why it is needed? That's why it's explained here because all the inputs in computer should be in binary format, right? So it's very important that all the data given and information coming out are in the form of binary, right? For example, if user feed the number decimal number 10, right? You can see it in the screen, but actually what is happening inside the computer, this is kept as a binary number, right? So here in this picture, you can clearly see in the number 1, user presses number 9 in the keyboard. Number 2, the processor is identify this as a not number 9 in decimal, but as the 00001001 in binary. So computer keeps it in the memory as a binary number. So third one, that number is displaying as number 9 on the monitor, right? So it's very important. This conversion is very important, right? It's from decimal to binary, binary to decimal. So this is the critical path. Okay, the first time, yes, it will be hard, but mark my words, this is not that hard, right? But you may need some mathematical skill here, right? Sometimes you may be weak in maths, but don't bring it into IT. This is very simple math. So if you have any questions, if it's not very clear, please do comment and ask because this is a very easy thing. Get it, right? So now we are going to convert a decimal number into binary, right? So basically what you have to do is divide that number continuously, repeatedly by 2. Division by 2, it's not very hard, right? You know, the multiple tables, 2 is very easy, right? So you have to divide continuously by 2 until the remainder is 0. right? This division is bit critical. It's not you divide it one time and stop. You repeatedly divide it until you get the remainder as 0, right? Then what you do is all the remainders, you are going to write it, and then you will get that particular number from, you have to write from bottom to top. Then you will get that number, the decimal number in binary format. Okay, I will explain you, right? So now we are going to convert number 13 of decimal. So you can see the base is 10. So this is a decimal number. You are going to convert it to binary, right? So 13, you take 13, you divide by 6, sorry, divide by 2. So what is your quotient? It's 6, right? Because 2 into 6 is 12. 1 is remaining. Can you see the remainder? 6 again you divide by 2. It's 3, right? 2 into 3 is 6. Do we have any remainder there? No. So no remainder, 0 remainder. Then you divide 3 by 2 again. It's 1. 2 into 1 is 2. You have 1 remainder. So you put 1. 1 you divide by 2. Is there any, it's 0, but you have a remainder of 1. So can you see in the right hand side, you have some remainders, but make sure you take those remainders from bottom to top. Bottom to top. That's how you get 1, 1, 0, 1. So that is the binary number. Understood? Don't worry, we'll do another number, right? There are a few examples, right? I will do one more, right? But if you follow these 3 simple examples, you can do anything, right? It's not very hard, right? Okay, 34. 34 you divide by 2, you get 17, and there is no remainder. Why you don't get remainder? Because 34 is an even number. If it's an even number, divide by 2, you don't get any remainder, right? Understood? Simple maths. So then 17, you divide again by 2, it's 8, because 2 into 8 is 16, but there's a 1 remainder. That's what right hand side you see a 1 in this box. Can you see? Then 8, you again divide by 2, you get 4, no remainders. 4 divided by 2, again the answer quotient is 2, you get remainders as 0. 2 again you divide by 2, you get 1, no remainders because 2 is an even number. So 1 you divide by 2, you don't get any quotient, quotient is 0, but you have a remainder of 1. Then in the box you can see few remainders, but you have to take from bottom to top. 1, 0, 0, 0, 1, 0. That is the answer. So you are converting 34 in decimal to binary. So the binary answer is 1, 0, 0, 0, 1, 0. Understood? Okay, we'll go for 49 as well. Right? So 49, it's an odd number. Okay, so 49, if you divide by 2, there is a remainder. So answer is, the quotient is 24. 24 again divide by 2. Quotient is 12, no remainders. Again 12 you divide by 2, you get quotient as 6, no remainders. 6 you divide by 2, the quotient is 3, no remainders. But 3 when you divide by 2, it's 1 and there's a remainder because 3 is not an even number, 3 is an odd number. So 1 divided by 2, you get 0 and you have a remainder of 1. So you have to take this box. So that is the all the remainders. So you have to take them from bottom to top. 1, 1, 0, 0, 0, 1. Understood? So I will do one question more, right? If you don't get it, right? Okay, so I'm going to get the number 101. So this is in decimal. I'm going to convert it into binary. So 101, this is 101. So you divide by 2, you get 50. 1 is remainder. 50 is an even number. When you divide by 2, you get 25 with no 0 remainder. 25 you divide by 2, you get 12. 1 is the remainder. 12 you divide by 2, you get 6, no remainders. 6 divided by 2, you get 3, no remainders. 3 you divide by 2, 1, but there's a remainder because 3 is an even number. So 1, again, you remember the last step. It's very important. Don't stop there. 1, you have to divide by 2. Then you get 0 and remainder is 1. Some teachers will not go for the last step, but that is also correct. There's another method, but I don't want to confuse you. So this is the textbook method. That's what I'm teaching you. But sometimes in the classes or in your school, teachers will stop a bit earlier. Then until you get the 0 quotient, they can stop a bit earlier. But if you are familiar with that, go with it. I don't want to confuse you all. That's why I follow the same method mentioned in the textbook. Okay. So it's also correct. No worries, right? So then you take all your right hand side from bottom to top. So that is how you get this answer 1100101 in binary. See, totally two different. 101 in decimal number system is not the same in binary. Can you understand? Okay, so let's go for the other thing. So if you want to have a real break, have a break here. Pause my video and then go for the other one because this is converting binary into decimal. So parents better, if kids are following this continuously, have a break here because it's another way mathematical section, right? So here what we are basically going to do is we have a binary number and we are going to convert it to decimal numbers. Now see, when you look it may be looking very complex, but it's not, right? So you have 10111. So you know this is the binary number. We are going to convert it into decimal. So in the binary number system, what are the place values? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Now, these powers you have to remember. You can study this. You can see there's a pink table, power of 2. 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, like that up to 2 to the power 10 is 1024. So this thing you should be very good at, right? So here now you have a number 10111. You have to start from the right hand side, right? So first number 1 should be multiplied with 2 to the power 0, that means 1. You look at the second line. Then there's another 1 into 2 to the power 1. That means 2. Then again there's a 1 into 2 to the power 2, that means 4. Then 0, actually you don't have to worry, just 0 into anything is 0. So don't worry about finding 2 to the power 3, what is that, 8, or don't worry, don't spend time for that, right? So those are the tricks, students, you have to learn. If it is any 0 into something, 0. So forget it. No need to find 2 to the power, what is the number, right? It's 0 anyway. So 1 into 2 to the power 4, 16. Now you have 16 plus 0 plus 4 plus 2 plus 1. You add all of them, 23. So that is the decimal number. Understood? Okay, we'll go for another number. 10010. Right? It's very easy, 3 zeros, right? So you can directly put first place, start from the right hand side, 0. Don't worry, 2 to the power 0 is 1. 1 into 0 is 0. Don't worry, just 0. Then 2 to the power 1, it's 2. 1 into 2 is 2. Then again 0, 0, just put it. Don't spend time for that. But next thing is 2 to the power 4. Remember the place values. Okay, don't confuse. It should be 2 to the power 4. So 2 to the power 4 is 16. 16 into 1 is again 16. So 16 plus 2 is 80. Make sure you put your base, especially 10 base is okay, but in this chapter it's you write that. But if it's base 2, in the early example, it's must to write the base. Otherwise, 0 marks. Don't bring your paper to your teacher and ask, teacher, I have done everything correctly. I just forgot to put the base like that. They won't give marks for you. Okay, so make sure you put the base. It's very important. Last one, not very easy. You have 5 ones, right? 1 into 2 to the power 0, that means 1 into 1, it's 1. 1 into 2 to the power 1, it's 1 into 2, that means 2. 1 into 2 to the power 2. So these place values you have to remember. So 1 into 4, that means 4. 1 into 2 to the power 3, that is 1 into 8, that is 8. 2 to the power 4 is the next place value into 1. It's 16 into 1, and that means 16. So you add everything, 16 plus 8 plus 4 plus 2 plus 1, you get 31, right? Okay, I will do another number. Yeah, it's a bit big number, right? This is my number 1010101010 with the binary. Yes, it's hard. Place values shall we quickly tell? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9. Those are the place values. And you have a lot of zeros. So very easy. First, like if you start from the right hand side, first thing is 0. So don't worry, 2 to the power 0 is 1, 1 into 0 is 0. Don't worry, just put 0. Then next one is 2 to the power 1 into 1, it's 2. Next one you can just ignore, put 0 because 0 into anything is 0. 1 into 2 to the power 3, 2 to the power 3 is 8, 8 into 1 is 8. Next one, just put 0, right? 2 to the power 5 is 32. 32 into 1 is 32 itself. Next one, 0 into something. So just put 0, no worries. Then 2 to the power 7 is 128. So into 1 is 128 itself. So put 2 to the power 8 into 0. Anything into 0, that means 0. So don't worry. So 2 to the 9, 2 to the power 9 is 512. So it's into 1 is 512. So add everything, you will get 682. So that's the decimal number which is represented by the given binary number. Got it? Okay. Binary representations of data, right? So the computers are using 1 and zeros, we learn. So actually it is representing on-off states, right? So on-off states we represent with 0 and 1s, right? So text, sounds, images, everything will be stored in the memory in the as the binary bit pattern, right? So it's very important you understand these concepts. So data you see, the humans are seeing as the left hand side, but actually in the computer side, it will be shown as binary numbers, right? Zeros and ones, right? So computers takes all the input in binary form, process them, and then you give the output into the correct format, right? Yeah. So input, text, images, sounds, anything can be there. So processing happens in the binary form, and then again the conversion happens from binary back to the text, images, sounds, anything, right? So that is the main concept, right? So all processes in the computer perform zeros and one, that means on-off state, right? So that's the main idea you have to understand, right? So see, again, they have given the same thing. Digital camera, you take image, you but convert it into one zeros, and then only the system unit is going to store it, keep it, right? So all activities in the computer, such as data input, right? Saving data in the memory and saving permanently, processing, sending process data. So everything is done based on zeros and ones. So inside the computer, they basically use the binary numbers. Symbols are zeros and ones. Understood? This is the summary. I don't want to explain it again. Same thing what we discussed. We basically learn about binaries and decimal, but don't forget they have introduced you about octal and hexadecimal. Can be having an MCQ on it, right? So basically we learn the conversions for binary to decimal and decimal to binary. They have given a nice summary for you. Small page, one page, very simple one. Main important thing you have to remember is how to convert binary to decimal and decimal to binary. So binary to decimal, you have to think about the place values and you have to multiply with the digit value. But decimal to binary, you have to divide the number continuously by 2 with the remainders, and finally you get the remainders from bottom to top. Very important, students. Don't make a mess. Don't take it from top to bottom. It's bottom to top. Understood? Yeah. This may be a bit hard or bit complex things to start at grade 8, but don't worry, it's not that hard, right? So here it is having maths in your IT. So if you have any questions, please do comment. Hope I explain my best. So if you haven't still subscribed my channel, please subscribe. It's Euclid Learning Local English Medium Academy. So if you like my video, please do click the like button and press the bell notification so you will get all the notifications when I upload a new video. And please do comment, right? Every word matters, right? Okay, so we'll meet with the second video then. Thank you.